Hi, welcome back, guys. So we have completed in the last videos, around six videos we did, where we completed the chapter one of Python. Correct. Now let's move on to the second chapter, which is flow control, where we are going to look into the conditional constraints, the looping constructs, the break and continue, and also the keyword called pass. So it's a very interesting chapter. In fact, this is going to be our essence for the business logic which we are going to create. So let's move on quickly. So if else, this is not new for programmers, but for anybody who is learning programming first time, and this is your first language. Now let me explain you what is if else. So you could see here the picture where a person takes a decision based on the direction. If this is the route he is looking for, then he will go this way or else this way, and there could be multiple signs also. So we call this as decision making. A decision making in programming, we represent this decision making using a diamond. You could see here if else flow chart mein in the diamond we have said greater than or equal to 60. If it is greater than, there will be two options: one is true, one more is false. True means one branch, false means another branch. So we call this as decision making construct. If else if is a decision making construct. Okay, it's not that just one condition, there could be multiple conditions, there could be nested conditions, there could be so much in if else if. You can create a ladder like structure and take multiple decisions, and when you do that you will make use of these relational operators, logical operators, which we studied right in the last session. So all these operators, whichever returns true or false, should be used. Please understand the condition should return true or false. Only then the if else if condition statement will work. Okay, look at the various things here. You can see here number equal to 10. If number is greater than 0, you have a code. If it is false, fine. If it is false, then you have the code after if that will get executed. Cool, getting that. If you want, you can also have a else part. If not this, this. Could see here in the bottom. If not this, this. Fine. This is called as else part. So if I don't have the else part, only the condition will check and the loop will get terminated. But in this case, the else part, the another code will get executed if that condition is not satisfied. If the condition is true, this code. If the condition is false, the else code. Getting this? And in Python, we also have, fine, like other languages, else if part. That is, you can have multiple conditions, and this else if is written as elif, elif. See here, if the condition is satisfied here, this code elif another condition, elif another condition, elif another condition. I can have as many conditions as possible. Else, the final part is else this condition. So this is how we do have conditional blocks, and this is the syntax of conditional blocks as far as our Python is concerned. So let's have a quick demonstration of this if else if, so that we understand the basics of this if else if conditions. So let's go to our playground. So here, let me say number equal to 10. So simple if else. Let me have a demonstration. If num is equal to 10. So here we are giving a relational operator and checking whether the condition is true or false. So once you have the statement, then you have to say colon. This is the syntax of if. And then you can have these statements. You can say print of when the value is 10. Whatever it is, whatever you feel like giving, fine, or whatever the logic demands, you have this. So let me run this. So here you will see the value is 10 because the condition is true. Okay, what happens if the condition is false? What happens if the condition is false? Nothing, right? Okay, I'll do one thing. I will now write something after the if. That is, this print belongs to this if. But if I write something outside, print, fine, last line, something like this. Now this will get executed, even though the condition is not true. Why? Because this does not belong to the if condition. This does not belong to the if condition. See here. This is another, I mean, normal line of program which has nothing to do with the if condition. If you want that to be associated with if condition, then you should have that in this way. Then you will not find that last line getting printed. Okay. So here, if I'm going to give like this, then this belongs to outside the if condition. So whether the condition is satisfied or not, the last line will always get printed. Even if the condition is satisfied, the last line will always get printed. Okay. So you can have one line or you can have multiple lines. It's up to you. Can I have one more condition? Yes, you can. You can have one more condition. We call this as nested ifs. Let's say I have one more, x equal to 100. So I can say if x equal to 100, and I can have like this, print x is 100. So this condition is satisfied, it will go to that condition and then this will get printed. See, x is 100. In case if x is not 100, if it is 200, then the other line will not get printed. Okay, what happens if x is 100 and num is not 10? So this condition itself is not satisfied. So it will not go into the nested if. We call this as what? Nested if. See this? Only last line is getting printed. So please understand this. Very important construct. We use this extensively in our programming languages. So done. So if nested ifs. Okay. What happens when you have a number different? Like 11 is there, fine, but I am checking for 10. In case if that fails, then what should I do? Go to the same hierarchy. You can also have else. Else is, in case if that is not satisfied, then what am I supposed to do? So I can say print the value of num is not 10. So this will get executed. Fine. What is the difference between last line and that? Even if the condition is satisfied or not satisfied, the last line will always get executed. Whereas this else will only get executed if this condition is not satisfied. See this? Oh, else, after else have a semicolon, sorry, colon, then only it will work. Okay, if I give 10, else part will not get executed, but last line will get executed. See, else part is not executed. Correct or not? Else part is not executed, but the last line is executed. So what is this we called as? If else. Under else also you can have multiple conditions. And believe me, under this if you can have one more if, one more if, one more if. Like that you can have as many ifs as you like. But again, that will be a problem at the end of the day. So we don't create a huge if else if. Fine. Instead, we can also try out like this. If num is equal to 10 and x equal to 100, you can also do like this. Then you can say print, find the value of num and x is correct. It is also possible if both, like truth table, where we have both the conditions are satisfied, true true, then it is true, right? So if it is true, then that will get executed. So you can also have a combination of several relational operators, and that also you can bring. So nested ifs can be avoided by using this kind of approach also. So both these options are there. Okay. Apart from this, you can also have multiple, elif. Here we don't have the word else if, we have the word elif. For example, here I can have in the same hierarchy elif. Elif num equal to 11. Fine, then what should I do? Getting that? If 11, then what should I do? Print when the value is 11. Cool. And this particular if now belongs to 11, does not belong to 10. If I want that to be belonging to 10, then I should have copied it inside, no, after this print. Anyway, if I give 11, then this will get executed and this will get executed. If I give 10, only this will get executed. Okay, look at this. I give 10. So the first print value is 10 is executed, then you come to last line, correct? This is from here. Okay, but if I give 11, what happens? The value is 11 and also x is 100. Getting that? So this is elif. Now multiple, I mean, programs can be written. Several kind of permutations and combinations can be done. I'll give one small program here. See here, I'll say input. Please enter a number. Please enter a number. Here I am going to find check whether the number is odd number or even number. Fine. N equal to n equal to here num equal to num percentage of 2, and this num has to be converted to int, correct? Typecasting, otherwise it does not get, because the incoming will be string. So have this, and once you have this, if n is equal to 0, say even number, else print odd number. Simple. So based on the value I pass 11, odd number. I pass 10, even number. Makes sense. And there could be multiple things which you can do with this. Or it could be like, please enter a day. And if num is equal to 0, it's Sunday. Please enter a day. Fine, 0. No holiday is coming. So what you have to do is comparing to a number. Okay, 0, it's Sunday. That was taken as a string actually. Okay, so think of, guys, in the lab book you will find many more exercises, or think of various things which you can do with if else. Okay, chali. So with that we'll conclude this if thing, and now let's move on. See, these videos are supported by lab books, right? These videos are supported by our panchatantra. These videos are supported by our question bank, and so many other stuffs: code of the day, test of the day, question of the day, video of the week, assignment of the week, lab of the week. Like that, we got so many things. And apart from this, we have exam papers, we have test papers, so many things. So obviously, you got to be my student to get all those stuffs. So these videos will is to ensure that education is there for all, and people learn from anywhere without worrying about the cost or anything, as a matter of fact. So this is all about teaching. Now if you want to learn, you have two choices. One, you learn by yourself, and I know 50% of the people learn. But if you fall in that 50% who needs much more, I mean, some more assistance, you can be, once you become a student, find how to become a student. For that, you have to get in touch with us, right? So visit my site, harrisinfotech.com. You'll find my contact details there. Fine, shoot a mail, shoaib at harrisinfotech.com. Fine, we'll reply you back on that. And even if you are a current student of mine, fine, if you feel that you have missed something, shoot a mail. I will send you the details based on that. Okay. Now let's move on to the next one. Loops. So after if conditions, the second most important thing of any programming thing is loops. Loops is doing one job repeatedly, doing a job repeatedly. There are three loops which are famous. One is for loop, one more is while loop, one more is do while loop. So all programming languages will have support for these loops. So for loops may we believe in this syntax for I in the collection. So basically we are going to iterate a collection. So we are going to run a loop so that we read all the values in that collection, and then we print it or we process it however we want. So if we want to do something repeatedly, we can make use of loops. And why we have three loops: for loops, while loop, and do while loop in any programming language. See, for loop is used when you are very sure about the number of loops which will happen. Basically, the scenario should be known. If you know how many loops is going to happen, or we have a definite structure for which we want to do a looping, for loop is the best bet. While loop and do while loop, you go when you are unaware of the number of loops which are going to happen or infinite loops, then while loop and do while loop is the best choice. Again, there is also difference. Why while, why do while? While is called as pre check, and do while is post check. The checking, the condition is checked after the loop starts in do while, and condition is checked before the loop starts in while. That's the only difference. So now let's see how this thing works. You can see here a for loop starts with initialization, then a condition. So if the condition is true, then a statement is executed, and there is a increment or decrement. Again, it goes back to the condition. So this loop will continue until the condition is satisfied. Once the condition is satisfied, it comes out of the loop. False. Making that, is that making sense? So let's see now how we can demonstrate this particular for loop in Python. Okay. So let's say I have a list, my list equal to. So by now you would have understood my list and all. So if I want to read the values of my list, I can very well say print of my list. Correct? Print of my list. This will print all the values. But if I want a particular value, I can say zero. Correct or not? I can say zero. So I'll get the particular value. So now the question is, I want to read the values, one by one, all the values. Then I got to either run this program four times, or I find out a way by which the program can be run automatically four times. Correct. So how do I do this? Now one of the ways to achieve this is, you can very well say for I in my list, I in my list, and then you can say my list of I. Now, what do you mean by this? I find my list. This is a for each loop. It will take each object of that particular list, pass it on to I, and what this will do is, you need not have I. You just take the I. It's not the number which is coming, it's the value itself, it's the object itself. It will give 10, then 20, then 30, then 40, and automatically it checks the end of the collection. And once it reaches the end of the collection, it gets disconnected, the loop gets terminated. See this? Getting it? There is one way of doing it. There is also one more way. You can also say find r equal to range of 4. R equal to range of 4. And then I can say, what is range? Range is also a collection. It generates a number between 0 to 3, because 4, You remember when we read the data types, in collection data types, we had set, list, tuple, dictionary, and also range. So range, I think we didn't saw the range. Fine, when we had that, no, I mean, chapter, first chapter. So let's see the range. Range will generate numbers from 0 to 3 if I've given 4. If I've given 5, it will generate 0 to 4. You could also do like this for I, sorry, in R, and then I can say print of my list I. So what this will do, this will print 0. Zeroth position is 10, one position is 2, sorry, 1, then 2, then 3. I have 3, right? In fact, if I want, I can print this range so that we know that how many numbers are generated. See this? Cool. Getting that? Fine. So fine. So here you have done it in two ways. One, you have done it directly using my list. Another, you have read a range, and through range also you have called. You have called. Is that clear, guys? Fine. So basically, for loop works like this. So for, then in I in R, whatever it is, or I in my list, then you can, read one by one, one by one, one. You can read. Getting that? So very interesting loop. See here. You can also have a else part. I mean, if all the items are, over, you can also have, this thing, else part. Now, how else part works? Let's see. Else print no more items. Let's run this colon. No more items. Okay, let's see what happens when we go out of range. Let's say I have 5. 5 means 0 to 4, right? 0, 1, 2, 3. Only 4 items are there. Since the index starts with 0, fine. I mean, this is going to exceed one number. So let's see how it works. So we are having a problem. List index out of range. So we are getting an exception. We are getting an error stating that the list is out of range. Got it, guys? Am I making sense? Fine. So you can also have a else part, which is very rare to, compared to other languages. Normally, in other languages, you don't have else part for neither in C or Java. Here in Python, we have that also. So I hope you would have understood two things very important. One is the if else if, another is the for loop. Both are very important constructs. Since it's 23 minutes, I'll stop this video and continue this chapter in the next video. Thank you very much.